Hey everybody, this is Mr. W. Our topic today is something called factor trees, sometimes called prime factorization. By the end of this video, you will be able to use factor trees to find the prime factors for the whole numbers up to 24. Let's just jump in. Write the prime factors for the following numbers. On a previous lesson, we wanted to memorize our first 6 prime numbers. They were 2, 3, 5, 7, 11, and 13. And that's from our previous video. Okay, so let's write the prime factors for 6 using the factor tree. I could factor 6 down to 2 and 3. Notice that 2 is a prime number, and so is the 3. So the prime factors for 6 would be 2 and 3. For 8, 2 and 4. 2 is a prime factor, but notice that 4 is not a prime factor. So I'm going to break 4 down even further on my factor tree, and I would get 2 times 2. So notice now that I have 2 times 2 times 2 for prime factors. Why do we have 2's? Notice that that's on our list. We couldn't have 4 because 4 is not a prime number. 12. 2 times 6. 2 is prime, but 6 is not prime. So we're going to break that down further. 2 times 3 is 6. And notice that now our 2's and 3's are all prime numbers. So the prime factors for 12 would be 2 times 2 times 3. Quickly, some vocabulary for today's lesson. Again, make sure you've watched the previous lesson on prime numbers. Prime numbers, quickly, are just whole numbers with exactly 2 factors or divisors, 1 and itself. For example, 5 is a prime number because 1 times 5 are the only 2. Remember, we said it's going to have to be 2 factors, and it's also divisors if we do inverse. So 1, 2, one of them is itself. 6 is not prime because you'll notice that we could make it more than one way, and we're using 1, 2, 3, 4 factors, not just 2. Remember that factors are the numbers that we multiply. For example, 2 and 3 in 2 times 3 equals 6 are factors. Remember that there are 2 types of numbers. Prime numbers have only 2 factors, and composite numbers have more than 2 factors. On our previous lesson, we said that 0 and 1, they're not prime or composite. All composite numbers, and this is probably more on the area that we want for this lesson, all composite numbers can be made by multiplying prime numbers. When we're doing factor trees, that's what we're doing. We're breaking them down into prime numbers. Some people sometimes say it's building blocks for numbers. You also hear the terms prime factorization and prime factors. Factor trees. I guess you suppose that this whole thing is a little bit like a tree, I suppose, and that's why they refer to this as factor trees. Remember, factors are these numbers here that we multiply. So for example, for 8, our prime factors are 2. We did this on the other page. 2 times 2 times 2. So we refer to this as a factor tree. Here's 8, right? Here are the factors. and it kind of makes this tree. It's kind of an odd looking tree, right? But the factor tree. Let's do some factor trees. Keep in mind, again, you need to know your first 6. That's not a rule. It would even be better to know more, but 6 is a good place to start. That was on a previous lesson. Our first prime, 6 prime numbers are 2, 3, 5, 7, 11, and 13. All right, let's just get started. 1, remember, is not a prime or composite number. So we cannot use a factor tree for 1 because we said on another page in another lesson that 1 is neither prime or composite. 2 is already a prime number. So it doesn't make sense that we would have to break a prime number into primes when it's a prime. Same thing for 3. You say, what do you mean? 2 and 3, you can see, are already prime numbers, so we don't need to do those. However, 4 we can do. 4, if we make a factor tree, would factor, our prime factors would be 2 times 2, and again, notice that we see the 2. These are prime numbers. 5 is already a prime number, so we don't really need to do that one. I'm not going to do that one. 6, we said on the previous page, the prime factors could be 2 and 3, and you can see here that 2 and 3 are on our first 6 prime factor list. So the prime factors for 6 would be 2 times 3. Let's try some medium problems. Don't forget our first 6 prime numbers are 2, 3, 5, 7, 11, and 13. The reason why these numbers are important is that when we do our factor trees, the numbers we see down here have to be among those numbers. 7 we cannot do because it's already a prime number. In fact, you can see here 7 right here, but we can do 8. 2 times 4, what are we done? No, 2 is prime, that's good, but 4 is not on that list. So now we go further and say, well, 4 is made up of 2 times 2. You'll notice now that all of these are prime. We're not including this number. Why? Because it's not a prime number. So we're only including the ones that we broke down. Our prime factors for 8 are 2 times 2 times 2. Notice that 3 times 3 is 9, and we have broken that all the way down into primes. So the prime factors for 9 are 3 times 3. 10, 2 times 5, right? And you can see 2, and you can see 5. So the prime factors for 10 are 2 times 5. 11 is already a prime number. You can see it right there. So we don't have to do a factor tree for 11. It's already prime. But 12, we can do a couple ways. So I'm just going to refer to this as the first way to do 12. We could say 2 times 6 equals 12, but is 6 prime? No. We can break that down to 2 times 3, and you will notice that our prime numbers would be 2 times 2 times 3, and those are the prime factors for 12. We could also do 12 another way, a second way. Let's just say if we did 3 times 4 equals 12, notice that 3 is a prime number, but 4 is not. So we're going to take 4 and break that into primes, and you'll notice that we have 3, 2, and 2. Those are all prime numbers. So our prime factors again. And remember, because of the associative property, you can write these in different orders and still be correct. 13 is prime. We said that before. 14, surprisingly easy. You'll notice the 2 and the 7. So our prime numbers are 2 times 7, also called prime factors. 15 is nice and easy. 3 times 5. And you'll notice that 3 and 5 are both primes. So our prime factors are 3 times 5. 16, a couple ways we could do 16. Let's just start with 4 times 4. Are we done? No, 4 is not prime, so we're going to have to take that a step further. To get 4, you would go 2 times 2, and we'll do that again here. Are we done now? Yes, we have all of our numbers are primes, so the prime factors for 16, 2 times 2 times 2 times 2. 17 is also a prime number, and we really could say memorize the first 7, right? And 17 would go right there, and it's not a bad idea to memorize that either, but like I said, we just started with the first 6. Couple more. Don't forget your first 6 prime numbers, 2, 3, 5, 7, 11, 13. We just said that 17 would be the next one. These are just a good place to start, right? Okay, let's break 18 down into primes. A couple ways you could do this. Let's just say if we said, well, 2 times 9, but are we done? No, 9 is not prime, but I can say that 9 is made up of 3 times 3. And you'll notice that the 2 and 3s are prime numbers, so we're going with our primes. So our prime factors for 18 are 2 times 3, which makes sense, right? That would be 6. And then times 3, 3 times 6 would be 18. 19 is prime, so technically you could add that to that list. 20, a lot of different ways we could do 20. Well, let's do 2 times 10. Well, 2 is prime, but 10 is not. But 10 is simply 2 times 5. And you'll notice that 5 is a prime number. Our primes for 20 are 2 times 2 times 5. And those are called prime factors. 21, surprisingly easy. There you go. 3 times 7, you see the 3 and the 7. So the prime factors for 21. In other words, we've broken down this composite number into prime numbers. We said it's like building blocks. 3 times 7 is 21. For 20, 2 times 2 is 4, and 4 times 5 would be 20. So it's that kind of thing. A couple more. 22 is surprisingly easy. 2 times 11. Notice that 11 is a prime number. I wrote it down twice. So our prime factors for 22 are 2 times 11. 23 is a prime number already. 24, a lot of ways you could do 24. Goodness, let's do 2 times 12. 12 is not prime, so I go, let's say 2 times 6, right? But 6 is not prime, so we're going again, 2 and 3. So now we have all of our primes. We can't break these down anymore. Notice that 2 and 3, once again, are on our list. Our prime factors for 24 are 2 times 2 times 2. I'm going to have to squiggle off a little bit like that, times 3. Remember, some composite numbers do have more than one way to go down to primes. Well, I was going to show you 24 two ways here. I just showed you the other way, starting with 2 times 12, right? We said 2 times 12, and we had 2 at the bottom. Sorry, I'm having a hard time with my paper here. 2 times 2 times 2 times 3. I wrote that a little bit neater there. So instead of 2 times 12, let's just say if somebody says, well, what about 4 times 6? Notice that 4 and 6 are not primes. So we would have to break that down even further. And you once again see that we have the same numbers we had on the previous page. Our prime factors would be 2 times 2 times 2 times 3. And I'm not going to do it another way for time's sake. Common errors, you may want to pause if you want. Here are some mistakes that we see sometimes, or I see for some of my students. Jim used a factor tree, that's supposed to say factor, okay, to find the prime factors for 12. He wrote 12, 3, 4. Did he do a good job? Is he correct? Well, if Jim had memorized his first 6 prime numbers, right, he would have said, well, 2, 3, 5, 7, 11, and 13. And 3 is great, right? But 4 is not. He would have had to go a step further, okay? And now he would have all primes. So this would be correct. So actually he was not correct. What mistake did he make? Well, we could say that very simply, that 4 is not what? 4 is not a prime number, right? And that's the mistake that he made. One more, errors. And pause if you want. Jen used a factor tree to find the prime numbers for 9. This is what she wrote. 9, 1 times 9. Is Jen correct? No or yes? Well, same thing. If Jen remembered her primes, that's our first 6, right? Is 1 a prime number? No. Is 9 a prime number? The answer is no, she is not correct. The right way to do that would have been to say, well, 9 would be 3 times 3. Notice that then both of them would be prime. So what did Jen do wrong? I'm just going to say that, well, she did not use her prime. So remember, when we're doing factor trees, the whole purpose is to break them down into what? Into prime numbers. You say, what do you mean? That's these guys right here. That's why we keep saying you want to memorize your first 6. It's not a rule. It's just that when you do this in 4th and 5th grade, these prime numbers will be the building blocks for the great majority of numbers that you will need to do. Final exam. Pause if you want. Find the prime factors for the following numbers. Should be easy, right? Keep in mind your primes. 13. 6 would be 2 and 3. In other words, the prime factors are 2 times 3. 8 could be 2 and 4 would be 2, 2. So in other words, 2 times 2 times 2, right? 12, a lot of ways we said you could do this one. Let's go with 2 and 6. 6 breaks down to 2 and 3. So we could say 2 times 2 times 3. All right, thanks everybody. Thrown a lot of information. You've done a good job. And we're going to stop it there and we'll see you next time. Thanks a lot.